Okay, so we understand three different ways of charging: diffusion, that is physical contact, friction, and induction. Now, there is one conceptual problem in NCERT which is quite interesting. I'm discussing that conceptual problem here. We have a metallic ball. Okay, we have a metallic ball. This is a metallic ball hanging with a silk thread, non-conducting thread. This is a non-conducting thread, and near to the metallic ball we have a highly negatively charged rod is there. Okay. Now the question is predict like what will happen after that. Okay. So we have a metallic ball. Now this metallic word is very important. If it is not mentioned, we cannot do. Or it may be like this: a conducting ball. Conducting ball. Conducting means there is a metallic in nature. Metallic. Okay. It is a metal. Conducting means it's a metal, and we have a highly concentrated negatively charged rod is there. Okay. So what are the things happening? Since it's a metallic ball, it has free electrons, and those free electrons are first what? It's a neutral body like this. It will be in this situation. Okay. Now after this, what will happen? What will happen? Plus these positive particles, charges, will attack that side. That means charge separation will occur like this. Okay. Charge separation will occur like this. Now, why this charge separation? Because this rod is fixed out here. This rod cannot move. But since this ball is hanging with a thread, this ball can swing like this. Okay. So initially, what is happening? The inside the metallic ball, the electrons and the protons will exert force. Okay. They will undergo a charge separation. Now there is an attractive force acting here. Since this becomes negative, this is plus here. There is some attraction now. Since this ball is hanging with a thread, now slowly this ball will move that side. Okay, that ball will move that side and it will stick to the rod like this. It will stick to the rod. Now when it touches the rod, now what is happening? This is a rod which is a negatively charged body, negatively charged, and this is a neutral body. Okay, which has a charge separation, stick. Now what will happen? These electrons will slowly undergo diffusion. Why diffusion? The concentration of electron is more here with respect to this area. So diffusion will occur. So what will happen? This body will have extra number of electrons. As this body will have extra number of electrons, now what will happen? This body will become negatively charged body, and this is also negative. So what will happen? Repulsion occur. Now due to this repulsion, this ball, metallic ball, will move this side, and okay, this rod is fixed. Now, why this ball is moving this side? Because there is some repulsive force acting in this direction. Okay, so slowly it will move, and in a particular position, it will remain at that point. Why? Now, the forces now, there are the three forces acting in this body. One is this repulsive force, another is tension, another is weight. Now, these three forces becomes in equilibrium now. So, this ball will incline itself at certain angle. This is called equilibrium position. It attains an equilibrium position where net force on this ball becomes zero. There are three forces, the net force becomes zero. So again I am repeating, the first thing will happen is what? Metal head, free electrons are there. This is the first case. It will undergo a charge separation. This plus and this minus will attract, and this ball will stick to the rod. Now due to the concentration difference, electrons will diffuse to the ball. As soon as the electrons diffuse, this metallic ball, it becomes a negative ball, and this is a negative rod. They will start repelling each other. Due to repulsion, the ball will go in opposite direction and will incline itself with some angle theta. Okay, and acquire an equilibrium position where the net force on the ball becomes zero. Okay. Now we will undergo the actual part of this chapter, that is Coulomb's law. Okay, Coulomb's law of electrostatics. Now, what is electrostatic charges at rest? We understood in the first video. If you have two plus charges, they will repel. If you have a plus and a minus sign, they will attract. This repulsion attraction are nothing but forces. Electrostatic force. Coulomb's law deal with that force. Okay, the force is between two charges at rest. Two charges at rest. So what that Coulomb's law say? Now, if you see the notes now, in the notes, the definition of Coulomb's law, I have made few words bold font. Okay, bold, dark किया गया है इसको. Those words you cannot miss when you write that definition in your boards. Okay, those words which are bold are very important. Okay, so the Coulomb's law deal with what? Point charges, 2 point charges at rest in vacuum. Vacuum, air or space. Theoretically, for me, vacuum, air and space all are same. But practically they are different actually. Yeah? So what the Coulomb's law say? If we have two charges, Q1 and Q2, there are 2 point charges. Now what is the meaning of point charges? Okay, try to understand. Point charges means what? With respect to the size of the charges. For example, this is the size of charge. The size means radius I am talking about. Is very small with respect to the distance between them. That means R is greater than the size of charge. If this occurs, then this charge becomes a, if this condition satisfied, then this charge, that those charges becomes a point charges. Okay. Okay. So now we have 2 point charges at rest, which is kept in a vacuum or space. So these 2 charges will exert force on each other. That force can be attractive, can be repulsive, depending on the, and whether they are plus or minus. Okay, let that force magnitude is this. Okay, this is the force acting. What the Coulomb's law say? If there are 2 point charges at rest, point charges at rest in vacuum or air or space, then the magnitude of force is proportional to product of the magnitude of charges. Okay, magnitude. If the charge is negative, we cannot take negative value. We have to only consider the magnitude value. And it is inversely proportional to the square of the distance between them. Okay, so these are 2 statements of Coulomb's law. First, it is proportional to product of the magnitude of charges, and is inversely proportional to square of the distance between them. So if I combine these two, what I will get? Mod of Q1, mod of Q2 by R square. Okay, so that is equal to some constant K, mod of Q1, mod of Q2 by R square. Okay, now this K is what? 1 by 4 pi epsilon naught. See, it says pi is E. C with a dash, पेड़ कटा हुआ एक C है, उसे पेड़ काट दो like this. C पेड़ काट दो. Naught, epsilon naught. We read it like this: epsilon naught. Okay, it's just a way of pronouncing this symbol epsilon. But what physical quantity it represents? It represents absolute permittivity. Okay, absolute permittivity of space. Its value you have to study from the definition. Okay. Okay. Now, when you are writing the definition in your boards, you write the definition what is in the boards, and you write this. This K value is 1 by 4 pi epsilon, valid only if you write this statement in vacuum in space. If you don't write in vacuum in space, then this is wrong. Okay. Since we have written in vacuum, that's why I'm writing K equals to 1 by 4 pi epsilon. After some time, we'll discuss about the K values thoroughly nicely. I'm now discussing only the definition. Is that okay, the definition? So what is definition say? Coulomb's law say that the force, electrostatic force, the magnitude of electrostatic force between 2 point charges at rest is proportional to product of the magnitude charges inversely to square of the distance between them. Okay, from there we get a K. K is 1 by 4 pi epsilon naught. It's a reading process, epsilon naught, but it's what is so absolute permittivity of space. Okay, now we will learn how to use this expression numerically. In mathematics or in numericals, when you face a numerical, how we use this expression. And then we'll study what are the values of K we need to deal with. Now, numerical concept. Okay, in numerical concept, what we will do? We will use simply this. F equals to K, Q1, Q2 by R square. We will not like mod, all those things. But we have to remember that we have to put only the charge values, not the sign. Okay? And then beside we write the nature, whether it is repulsive or attractive. We write the nature of the force. So in numerical we write the formula like this. We will not use mod. But again I am saying we will not use mod. That doesn't mean that we can use a sign. We cannot use a sign. Okay? We can use only the magnitude of the charges. Okay? Now let's discuss about the value of K. Now K value depends on the charges are kept where. Okay? So in the first case, if in the question it's not mentioned in which medium the charges are kept. Okay? In which medium the charges are kept is not mentioned. So we will consider it as air. Then the K value is 1 by 4 pi epsilon naught. Okay? Epsilon naught value is fixed. So the overall this calculation is 9 to the power 9. So we use this value in numericals. But if the medium is other than air, हवा, दूसरा कुछ है, पानी है, तेल है, okay, something else, oil, water, then the K value will be 1 by 4 pi epsilon naught epsilon r. Now this value we know, 9 into 10 to the power 9 divided by epsilon r. Now, what is epsilon r? This is called as relative permittivity. Okay, of medium. Relative permittivity of medium. Depends on medium. Water has a different value. These values will be given to you in the numericals. Don't worry about it. Okay. So you understand the values of K. You understand what it will do in the numericals. Done, class. Now we'll go for Coulomb's law in vector form. How to write the Coulomb's law in vector form. Now, to understand the Coulomb's law in vector form, we must know the concept we studied in class 11 in chapter vector. If we have to write any vector, how to write the vector? Magnitude of the vector and unit vector. Any vector, A vector is written as equals to first is magnitude into its unit vector, right? Okay, then what is position vector? These things you should know. A small revision of class 1. What is a position vector? Position vector is a vector of a point. If this is a point A. Now what is the position vector? Origin to that point. This radius vector, OA vector, is the position vector of point A. Okay. Similarly, we have another point B. What is OB vector? This is a position vector of point B. Now, if I say I want AB vector, what is AB vector? Opposite, AB, position vector of B minus position vector of A. If I make BA vector, B to A to B, BA vector, then what will happen? Ulta. Position vector of A minus position vector of B, like this. Okay? So these knowledge we will use now here. Now let's take a Cartesian coordinate format. This is x coordinate, this is y coordinate. We have two charges here, Q1 and Q2. Okay, both charges I am taking it as positive. Now Q1, the position of Q1, position vector is R1 vector. Position of Q2 vector, Q2 is R2. Like this charge is Q2, like this charge is Q1. Both are plus. Okay. The position of Q2 is R2 vector, the position vector of Q1 is R1 vector. Now since they are positive, what will happen? This plus plus, they will repel this charge due to this charge. It will repel like this. Okay? And this charge due to this, it will repel like this. So what is this? This is a force on Q2 due to Q1. Force on 2 due to 1. This is what? Force on 1 due to 2. Okay? Clear? Now, the forces, force on Q1 due to Q2 and the force on Q2 due to Q1, both are same. Magnitudes are same. What is the magnitude? K Q1 Q2 by R square. Okay, the magnitude are same. जो भी फोर्स ये इसको लगाएगा ये इसको लगाएगा, वो फोर्स का वैल्यू सेम है, क्योंकि वो फोर्स का वैल्यू किस पे डिपेंड करता है? उनके चार्जेस के वैल्यू पे, उनके डिस्टेंस के वैल्यू पे. This is the distance between them. If I say this is Q1, if I say this is Q2, now what is this? R12 vector. And what is this? R21 vector. 2 से 1. So R12 vector and R21 vector, they are equal. Magnitudely they are equal on the direction opposite. That is R. This is R. Okay. So now see, for finding any vector, I need this magnitude, I need this unit vector. What is my job? My job is to write Coulomb's law in vector form. That means I need to write Coulomb's law means what? The force in vector form. So vector form is equals to its magnitude into unit vector. That formula we are using. A vector equals to magnitude into unit vector. So magnitude, I already know. Now we are interested in what? Unit vector. Okay. Now we know standard unit vectors are I, J and K. I towards x-axis, J towards y-axis, K towards z-axis. Now what is F12? F12 is going in this direction. It is neither x nor y nor z. Now if it was x-axis, I would have written I cap here. If it is y-axis, I would have written j cap here. So since this is not any standard unit vector, this direction, so I will assign a unit vector on my own. From 2 to 1, this is a unit vector named as R21 cap. So what is R21 cap? I am assigning a unit vector which is showing the direction from 2 to 1. Similarly, R12, 1 to 2. This is a unit vector. This is a unit vector showing the direction from 1 to 2. Now F12, this is the force on 1 due to 2. It is going this direction. This direction. So this direction is unit vector this. This is unit vector which is showing this direction. So I am writing here R21 cap. You understand here? Don't mug it up like a symbol 1 2 1 2. Here should be 1 2. No. 1 2 is the force. Which direction? This direction. Which unit vector I have assigned? R21 cap I have assigned. Okay. Now we can substitute the values directly. K Q1 Q2 by R square R21 cap. Okay. Now I don't want my answer. We already got the vector form, but I don't want my answer in terms of cap. So what I will do? R21 vector is equals to what? R21 vector magnitude into R21 cap. Again, A vector is equals to mod of A vector into A cap. Okay, so from there R21 vector by R21 vector magnitude is equals to what? R21 cap. So I am substituting this value here. K Q1 Q2 by R square. This I can write R21 vector by R21 vector magnitude. Okay class? Now see, R is R21. There also R21. So we can write like this K Q1 Q2 R21 vector magnitude whole square. Like this R, we can write R21. Okay, now this becomes cube. So what I got? F12 vector is equals to K Q1 Q2 by R21 vector ka whole cube into R21 vector. Okay. Now here we studied AB vector is what? position vector of B minus position vector of A. Similarly here, R21 vector, 2, 1. Now how to write? R21 vector, position vector of 1, R1 vector minus position vector 2, R2 vector, 2, 1, opposite. Pehले 1, फिर 2. So I can write like this, R1 vector minus R2 vector का mod whole cube, R1 vector minus R2 vector. This is mod, this is bracket. We got F12 vector in vector form. Okay. Similarly, if I want to write 2, 1 in vector form, so we have to first write its magnitude, then its direction. 2, 1. 2, 1 is which direction? This direction. This direction. In this direction, which unit vector we have assigned? This one. So this is R12 cap. Further, if you do in the same way, what I will get? K, Q1, Q2 by R2 vector minus R1 vector mod cube into R2 vector minus R1 vector. So this is a Coulomb's law in vector form. Okay. Now there are some special characteristics of Coulomb's law. Okay, which is there in the notes. You can study one by one. We will discuss here. First, it is a central force. What does that mean? What is the meaning of central force? Where is the first characteristics? Central force. Now, what is central force? For example, there are two bodies, two charges, Q1 and Q2. They repel each other. I am saying they are going like this. This is also repulsive, right? Far, they are going far away from each other. But this is wrong. What the Coulomb's law say? The Coulomb's law say the force which will exert. Here the force is going in this direction. This is force. This is force. But the Coulomb's law said the force is a central force. Central force means what? If you join both the centers of the charge, the force will act in this line. It cannot act anywhere. It will act in this line. That means the force will act like this, or attractive or repulsive. But whatever the force will act in this line. The line joining both the centers. That's why it is called central force. Next, conservative. Coulomb's force is a conservative force. Now, this word you have used lots of time in class 11. Okay, gravitation chapter. Conservative force. Conservative force means what? Due to this Coulomb force, any work is done. It depends on initial and final point, not on the path. Like what I want to say is that there is a charge Q1, there is a charge Q2. Due to this Q1, this charge Q2 experience a force. Listen very carefully. Due to this Q1, this Q2 experience a force, and this Q2 reach here after some time. ऐसे करके चला गया after some time. Okay. अब since कंजर्वेटिव फोर्स है, इस पाथ को फॉलो करें या इस पाथ को फॉलो करें, इन बोथ द वेज वर्क डन का वैल्यू, मान लो यहाँ W1 है या W2 है, दोनों वर्क डन का वैल्यू सेम होगा. ओके, क्योंकि इनिशियल एंड फाइनल पोजीशन सेम है. दैट्स द मीनिंग ऑफ कंजर्वेटिव फोर्स. ओके, नाउ नेक्स्ट, दिस इज क्वाइट इंटरेस्टिंग. What the Coulomb's law say? There is a force between two charges. If there is a plus sign, they will attract, they will repel. If there is a plus minus, they will attract. Let's get inside a nucleus. Nucleus. एटम के अंदर क्या होता है? न्यूक्लियस होता है. न्यूक्लियस के अंदर क्या होता है? प्रोटॉन्स होते हैं ना. ये न्यूक्लियस है, इसके अंदर we have protons like this. We have neutrons also. These protons should repel, isn't it? प्लस है, रिपेल नहीं करेगा ना. बट साइंटिस्ट लोगों ने पता किया कि इनसाइड न्यूक्लियस प्रोटॉन डोंट रिपेल, प्रोटॉन अट्रैक्ट. अब तो पूरा कचरा हो गया. कचरा क्या हो गया, कूलम्स लॉ तो बोलता है रिपेल करेगा. So this is the limitation of Coulomb's law. Okay. Then the distance between two charges R is similar to 10 to the power minus 15 meter. That means दो चार्ज दिया मैंने, उसको बहुत दूर लेके गया तो कूलम फोर्स लगेगा. मतलब अगर प्लस प्लस पर रिपेल करेगा, लेकिन उसको नजदीक लाना, नजदीक लाते 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 उनकी जो डिस्टेंस है वो अगर इसके बराबर हो गया, इससे कम हो गया, तब कूलम्स लॉ नहीं लगता है, कूलम फोर्स नहीं लगता है. ठीक है. इनसाइड द न्यूक्लियस एक नया फोर्स लगता है जिसको हम बोलते हैं न्यूक्लियर फोर्स. कूलम फोर्स नहीं बोलते हैं, क्या बोलते हैं उसको? न्यूक्लियर फोर्स बोलते हैं. ठीक है. सो दिस इज लिमिटेशन ऑफ कूलम फोर्स. दैट इज वैलिड. It is invalid when the distance between, it is invalid when the distance between two charges is less than or it is approximately nuclear range 10 to minus 15 meter. Okay. Next, कूलम फोर्स जो है वो टू बॉडी इंटरैक्शन. व्हाट इज द मीनिंग ऑफ टू बॉडी इंटरैक्शन? टू बॉडी इंटरैक्शन क्या होता है? व्हाट इज दिस? फॉर एग्जाम्पल, वी हैव टू चार्जेस Q1 and Q2. Force between these two charges is what? K Q1 Q2 by R square. Right? Suddenly, one more charge I have kept here. Suddenly, okay? एक और चार्ज रख दिया. अब क्या होगा फोर्स इन दोनों के बीच का? सेम रहेगा ना. इन दोनों चार्जेस के बीच का जो फोर्स है वो किस पे डिपेंड करता है? उनके चार्जेस पे डिपेंड करता है, उनके बीच के डिस्टेंस पे डिपेंड करता है. तीसरा चार्ज है या नहीं है उस पर डिपेंड नहीं करता. What I'm going to say is that's called two body interaction. The force between two charges is irrespective of the presence of third charge. Whatever the force is acting, that force will remain same whether we have a third charge is there or not in the vicinity. Understand? That is called as two body interaction. Okay, that's all. So first you go through these things, go through the notes, go through the videos. If it helps you, please let me know so that I get an appreciation. I get a motivation to make further videos for you guys. Okay, so contact me. Thank you.